Hello and welcome back to the channel. I am the GCSE Science Teacher, and in today's lesson, we're going to be discovering all things to do with the atom. Content covered today will include atoms, elements, molecules, and compounds, electron structure or configuration, and relative charge and mass. So let's get started. Let's start off by defining atoms, elements, compounds, and molecules. Atoms are the smallest part of an element. Everything around us is made up of atoms, including you and I. But what is an element? Well, it's a pure substance. It's made up of only one type of atom, and this could include sodium, Na, carbon, C, and potassium, K. For the GCSE exam, you will be given a periodic table, and you need to be able to recognize the first 20 elements that are there. And this is very useful when balancing equations, looking at bonding. It also is useful for the biology topics as well. Compounds and molecules are how atoms are chemically bonded together. So, a compound is when two or more different atoms are chemically bonded together. An example being carbon dioxide, which is a gas. Carbon is the green circle you can see there. And there are two oxygen atoms that are also chemically bonded to the carbon atom. You also have molecules. Molecules are two or more of the same atom that are chemically bonded together. For example, another gas is oxygen. That's a diatomic molecule because there are two atoms that are chemically bonded together. So let's look at the structure of the atom. You have the nucleus, which is where all the mass of the atom is found, or most of the mass at least. And it's also overall has a positive charge. And this is because of the protons which are found within the nucleus. Not, by the way, to be mistaken with the nucleus of a cell. And if you're not sure what I'm talking about, go check out my video on cell structure so you are in the know. Also, in the nucleus, you find neutrons. Now, these have no charge at all, but they do contribute to the mass of the atom. The last but not least, the third subatomic particle is the electron. Now, electrons are negatively charged, and they are found orbiting the atom in what we call electron shells. Sometimes they're also called energy levels as well. The rest of the atom is actually just made up of empty space, and the atom has actually changed. What we once thought the atom looked like is actually changed over time, and I'll have a video on that, which you can check out on my channel too. At GCSE, you need to be aware of electron configuration, and this is just how many electrons are actually found in different atoms. So there's a rule that you need to be aware of, and it's called the 288 rule. And what that means is how many electrons can fit into each shell. So the first example you can see, we've got just a normal atom. You can see we've got two electrons that are in green, two protons in blue, and two neutrons in white. Notice that the number of protons is equal to the number of electrons, and that's the same in every case of an atom. One thing to note is as the atom gets bigger, the electrons need to find different shells to fit into. So the first shell, you can only fit two electrons in. The second shell, you can fit at most eight, and the third shell, you can also fit another eight electrons. But in the case of the third example, you can see that the first shell is full, there's two there. The second shell is also full, there's eight. But the third shell, there's only one electron that's in there. And that means there's an opportunity for another seven electrons that could fill up that shell. Something also to be aware of, by the way, in my diagram, I've actually not drawn out all of the protons and neutrons in this second and third diagram, just because it'll get quite messy. Remember, the number of protons is equal to the number of electrons, and in those two pictures, the nucleus would be quite full. So I'm not drawing that one in just to keep it nice and simple. So I've just put a big black dot there instead. The fourth example, I've not actually given you the electron configuration because I want to see if you can tell me in the comments below what is the answer? What is the electron configuration for that atom? One of the take home messages from here is just to know that electrons will always fill the shell nearest to the nucleus, the lowest energy level. And remember, that's because electrons have a negative charge and protons have a positive charge, and they are attracted together. So they want to be close together. Speaking of charges, let's talk about relative charge and relative mass. So, even though protons have a positive charge, a +1 charge, and electrons have a -1 charge, the overall charge of an atom is zero. And that is because the number of protons is equal to the number of electrons in an atom. Now, you can actually have opportunities where electrons can be gained or lost, or shared, we should say, and that can affect the overall charge of an atom later on. But that's more to do with bonding of atoms, and we'll talk more about that in future videos. One thing also to note at this point is the relative mass. So, because atoms are so small, we can't say that they weigh or they have a mass, I should say, of 10 grams or 0.01 gram. Okay. We actually just say relative mass, how big they are compared to one another. So, protons and neutrons all have a relative mass of 1, whereas an electron is less than 1. Okay. Which means that electrons are the smallest part of the atom in terms of mass. One thing also to note is the mass number and atomic number, and you'll come across this often in chemistry, but it's worth mentioning now. In the example here, this atom is a sodium atom, the symbol Na. We have the mass number of 23. That just means in a sodium atom, the number of protons and neutrons are 23. There's 23 total. Okay, the atomic number is the number of protons. So this means that in the sodium atom, there are 11 protons. Now, if you remember what I said, the number of protons is always equal to the number of electrons. So if there's an 11 protons, that means there's also 11 electrons too. Now, if we wanted to use that to work out the number of neutrons, we would simply do 23 minus 11, and that would give us an answer of 12. So the answer for how many neutrons there are in a sodium atom, we would say 12. Thank you so much for watching. I hope that was helpful. Please like, comment, subscribe, and follow me on Instagram for more or to DM me for video requests. I've been the GCSE Science teacher, and you have been curious. Take care, and I'll see you in the next video. Bye.